In the silent void beyond Earth's blue embrace, a sound emerges. Not thunder, not whisper, but a chirp. A bird song from the cosmos, echoing across the vastness of space. What is its origin? And why does it remain a mystery? This is NASA's cosmic chirp, and its story is only just beginning. Above our heads, beyond the blue skies, and past the pull of Earth's gravity, lies a realm so silent it defies imagination. Space, a vacuum, a void where sound should not exist. And yet, in early 2025, NASA heard something. A sound, a whisper, a chirp, faint but unmistakable. It wasn't a glitch, it wasn't noise, it was real, recorded over 62,000 miles above Earth, where no birds fly and no wind blows. What they heard was a song, a pattern, a rhythm, a series of chirping tones echoing through the emptiness, like birds calling to each other at dawn, only this dawn was cosmic. NASA's magnetospheric multi-scale mission, 4 spacecraft dancing in perfect formation, caught the signal. Orbiting deep in Earth's magnetotail, where the planet's magnetic field stretches like taffy into space, they picked up something extraordinary, a chorus wave, the sound of electrons, trapped in magnetic fields, spiraling, bouncing, and singing across the void. A voice from the edge of the magnetosphere. Scientists listened and were stunned. It was beautiful, alien, familiar. It was a sound Earth had been singing for eons, but only now could we truly hear it. Imagine a melody, not played on strings or sung by voices, but composed by invisible particles moving through an invisible field. This is the language of chorus waves, the alien music of Earth's magnetosphere. What NASA heard is not a sound in the traditional sense. It's electromagnetic energy, radio waves created by electrons trapped in Earth's magnetic field. As these energetic particles swirl, twist, and collide, they emit bursts of radiation. In space, this becomes a chorus of rising and falling tones, chirping, whooping, pulsing. It's called a Whistler mode wave, and it sounds like a song. This phenomenon isn't new. It's been recorded before, usually within Earth's radiation belts, where energetic electrons drift like ghosts. But this time, the chorus was heard far beyond expectations, far beyond the orbit of GPS satellites. Deep in the magnetotail, the region where Earth's magnetic field is pulled into a long ribbon by the solar wind, the MMS spacecraft captured something extraordinary. A chorus wave so clear, so strong, it shouldn't have been possible. At that distance, the magnetosphere thins, the field weakens, the region grows unstable, and yet the melody was there, as if space itself was singing. The deeper we listen, the stranger it gets. NASA's instruments had captured the sound. The data was clear, but the mystery was only beginning. Where exactly did this sound come from? The magnetospheric multi-scale mission, 4 satellites flying in perfect tetrahedral formation, was designed to measure magnetic reconnection, the violent snapping of magnetic lines in Earth's magnetosphere. But what they heard wasn't just reconnection. It was a chorus wave, yes, but louder, stronger, and further than ever recorded before. 62,000 miles from Earth, in a zone where no strong waves were expected, a place scientists believed to be relatively quiet. Why was the wave so strong there? What was feeding it? And if these waves could form so far out, what else could be out there, humming in the dark? James Birch, the MMS principal investigator, admitted, "This tells us chorus waves can be generated in places we didn't think possible." And Allison Janes, a space physicist at the University of Iowa, said, "It raises new questions about how these particles move and what invisible forces are shaping them." In short, we don't fully understand what we're hearing. Because if waves like this can form in Earth's magnetosphere, What happens in the magnetic fields of other planets, of stars, of galaxies? Is this just a local whisper, or part of a universal song we've only just begun to hear? We were taught that space is silent. No air, no sound, just a cold, eternal stillness. But space was never truly silent. We just didn't know how to listen. From the soft pulses of plasma waves to the distant hum of magnetic storms, space is filled with vibrations, energy traveling through invisible oceans of charged particles. What NASA captured wasn't just a sound, it was one note in a vast cosmic orchestra. All across the universe, planets with magnetic fields sing their own songs. Jupiter, with its immense magnetosphere, screams with radio bursts louder than anything on Earth. Saturn hums in eerie, rhythmic tones. And now, Earth has joined the choir with a chorus wave heard from its distant magnetic tail, but it doesn't stop there. In the Perseus galaxy cluster, 250 million light-years away, scientists discovered pressure waves rippling through hot gas. The goal? To map chorus waves in 3D. To find out where exactly they are born, how they move, and why they suddenly rise like a wave of music, then fade back into silence. And we're not just listening to Earth anymore. We're listening to the Moon, planning to install magnetometers on Artemis missions. We're listening to Mars to see if its decayed magnetic field still whispers remnants of its ancient power. We're listening to deep space, using satellites beyond Earth's orbit to detect plasma vibrations from solar storms, asteroid belts, and even interstellar space. This is more than exploration, it's translation. We are learning the language of the universe, not with words, but with waves. One day we may tune into a signal not from a planet, but from another civilization. A structured rhythm, a purposeful tone, not just natural noise, but intention. A voice calling out across the void, but even if that day never comes, one truth remains. The universe is not silent. It never was. It speaks in radiation, pulses in magnetism, and sings in plasma. And we are the first species to stop, to listen, and to try to understand. For centuries, we believed space was silent, a void, a vacuum, an emptiness beyond imagination. But maybe we were wrong. Maybe silence was never empty. Maybe it was just waiting for someone to listen. The chirp NASA heard was not loud, not dramatic, not earth-shattering. It was subtle, software almost shy. But sometimes the smallest sounds carry the deepest truths. Because in that moment, when the chorus wave echoed across 62,000 miles of space, it told us something extraordinary, that the universe is alive with motion, that even in the blackest corners, particles dance, collide, create rhythm, and in those rhythms lies information, clues, mysteries, maybe even meaning. Every star, every field, every collision of energy, it's all playing in sync, like a grand, invisible symphony of matter and magnetism. The silence wasn't silence at all. It was the background hum of creation, and we're only now beginning to hear the beat. With discovery comes wonder, but also responsibility. Because if we are now listeners of the cosmos, then we must also be its interpreters, its protectors, its storytellers. NASA's discovery reminds us that space is not just a place, it's a conversation, an ancient dialogue written in fields and frequencies. And now that we're part of it, we must choose how we respond. Will we simply harvest data, or will we seek understanding? Will we use this knowledge to protect our technology, or to push deeper into the physics of stars, the birth of galaxies, the origins of everything? The choice is ours, because the more we hear, the more we realize. We are not just observers of the universe. We are part of its music. The earth sings, the cosmos hums, and our machines are the ears. The future belongs not to those who speak the loudest, but to those who learn to listen deeply, patiently, and with wonder. What began as a chirp has become a calling, a whisper from the edge of our world, now echoes through the minds of those brave enough to chase it. It was never just noise. It was a message, not in words, but in waveforms, not in language, but in vibration. The universe has been speaking all along, through magnetic fields, through plasma storms, through the breathless quiet between stars. It sings. And now, we are here to listen. This is no longer the age of rockets. It is the age of resonance, the age of those who look to the stars and finally ask not what they look like, but what they sound like. The cosmic symphony has begun. And Earth is no longer silent. Earth has found its voice.